All right, we're asked to consider the function f of x is equal to ax plus 1 all over bx plus c. And we're shown a graph. We're shown a graph of the curve of f of x squared. Okay, f of x squared. And we have some asymptotes here, and we also have one x-axis intercept. So I went ahead and wrote out what y is equal to. So this is the sort of equation of my graph here. Okay, this is the equation of my graph. And we're going to kind of use this in order to figure out what our vertical and horizontal asymptotes look like in comparison to f of x. All right, so taking a look at the vertical asymptotes for my graph, f of x squared, we're going to set our denominator equal to, so bx plus c quantity squared equal to 0, right? Well, that's true only when bx plus c is equal to 0. So here x is equal to negative c over b. Okay. Now, given what we know in the graph, negative c over b, that's just equal to p. Okay. Okay. Now, in order for this to be true, right, we know that either c or b could be negative. Okay, they could be negative, and if c is negative, then b would have to be positive or vice versa, right? So c and b are going to have opposite signs. Okay, now taking a look at the horizontal asymptote. So that's why I went ahead and expanded this, right? Because it's going to be the ratio of these leading coefficients, which would be a squared over b squared. And that's going to be set equal to y, which we can think of as a over b quantity squared. And we can see from our graph that a over b quantity squared is set equal to q. Okay, so I'm just going to leave that to the side for now. And then I'm going to think about the vertical and horizontal asymptote of f of x. Okay, so not just looking at f of x. And again, f of x is up here. Okay, so my vertical asymptote is going to be when bx plus c is set equal to 0. And I get the same x is equal to negative c over b, right? And that's going to be set equal to p. That's the same thing that we found up top. Okay, and doing the same thing for my horizontal asymptote, looking at f of x, okay? Looking at the equation of f of x, that horizontal asymptote being the ratio of my leading coefficients, that's going to be a over b, right? So it's going to be my horizontal asymptote there. Okay, now I got to think about if q was equal to a over b quantity squared, right? Because it's asking us in part A to graph the two possible graphs of f of x, giving equations of asymptotes in terms of p and q. Now we figured out here that my vertical asymptotes are just going to be the same thing that we have for our graph up top. X is equal to p. Okay, and x is equal to p. Okay, however, I need to think about how I can represent my f of x horizontal asymptote in terms of q, right? So I need to get this equation here to sort of match what we found here, right? So a over b is what we need to solve for in this case. So we're just going to take the square root of both sides. So when I do that, I end up with plus or minus square root of q is equal to a over b, which we said is the equation of our horizontal asymptote. So I'm going to have two cases here. I'm going to have the case where y equals positive square root of q, but I'm also going to have the case where y equals negative square root of q. Okay, so we have these two different situations here. All right, and we also want to take a look at this value a here, right? That is our x value or our x-axis intercept. And hopefully we can see that that is only going to be when ax plus 1 squared is equal to 0. So if I solve that, this is looking at y here. I'm just going to kind of separate this out. So when I'm looking at y, so this function up here, right, that's our f of x squared. If I solve this, x is going to be equal to negative 1 over a, right? However, if I take a look at f of x, right, and I set my numerator equal to 0, so ax plus 1 equals 0, we get the same expression, right, for x, which tells me that f of x and f of x squared are going to intercept the y-axis, the x-axis, sorry, at the same time, okay, at the same x value. Okay, so with that in mind, both of these graphs that I have here on the left of my screen need to intersect the x-axis here at point A. All right, so with that in mind, I know that I'm either going to have a graph for both of these that looks like this, right, or I'm going to have a graph that looks like this. Okay, so we can decide which one it is, because if I had a graph on the left-hand side here that looks like this, well, we can see that that's not intersecting the x-axis at that point A, right? So that's going to tell me that I have a graph that ends up looking something like that, okay? And likewise, on the right-hand side here, we need to intersect at A, okay? So we're going to end up with a graph that looks something like this, okay? All right, so that should do it for part A. Now for part B, okay, we're given values for P and Q, and we're told what the coordinates are for point A. So with that in mind, if A is equal to, so our x-axis intercept is happening at x equals -1/2, well, we found that that's equal to -1/A, which tells me that A needs to be equal to 2, all right? And we also found really expressions for P as well. We know that P needs to be equal to -C/B. We found that up here. Okay, so if that's equal to 4/3, that's equal to +4/3, right? That tells me that I have two cases, right? One case is where C is going to be equal to +4, in which case B would need to equal -3. Okay. And then we also have case 2 where C could equal -4, in which case B would need to equal +3. Okay, so that is one approach to solving a problem like this.